Welcome to another deep dive.
Great to be here.
Today we're tackling a topic that honestly hits close to home for millions globally. Peanut allergy.
It really does.
It's far more than just, an inconvenience. For so many people, it's this constant life-threatening risk.
It dictates daily choices, absolutely.
You listening might know someone living with it, or maybe you yourself navigate this really challenging landscape every single day.
Yeah.
For a long, long time, the only real strategy for peanut allergy was, strict avoidance and carrying rescue medication. And that always left me wondering.
What else could be done?
Exactly. What if there was another way? A way to actually change how the body reacts to peanuts?
And that's where the science has gotten really interesting.
That's the powerful question the sources we're looking at today truly begin to answer.
What's striking here, I think, is the incredible evolution. How fast our understanding and treatment options have changed.
It feels like warp speed sometimes.
It does. So we're going to walk through 3 pivotal scientific papers. They really map out the journey of a specific oral immunotherapy, AR101.
Which is now known as PTAH, right?
That's the one, PTAH.
Right.
We'll look at its initial trials. Did it even work?
The basic efficacy.
Right. Then the long-term benefits for patients and even the really intricate immune system changes it triggers. It's fascinating stuff.
It really is.
And this raises a fundamental question. Just how deeply can we reshape these allergic responses? Can we actually retrain the immune system?
Okay, so our mission today is clear. We'll pull out the most important insights from these key sources for you.
We'll start with that initial breakthrough trial.
Then move into how treatment held up, over time, longer term.
And then dive deep into the immunology, the how behind it all.
Get ready for some genuinely surprising facts, I think. Stuff that could really change how we manage peanut allergy going forward.
Let's dive in.
Okay, first let's set the scene a bit more. Understand the challenge we're dealing with.
It's important context.
Peanut allergy is definitely on the rise. Especially among children. You see it in the U.S. and other industrialized countries.
So yeah, the prevalence has shot up.
And it typically lasts a lifetime. And this is the really chilling part. It accounts for the majority of food allergy-related deaths.
That's a stark statistic.
Yeah.
It really highlights the severity.
So before these recent advancements, the standard of care was just a strict elimination diet.
Imagine having to scrutinize every single food label, every meal out.
Total vigilance. And carrying rescue meds like epinephrine. Always.
But, as you can imagine, accidents happen.
They do. Accidental exposures are a constant risk, often with really unpredictable severity.
And this creates just immense challenges. I mean, despite that constant vigilance,
It's always there.
it's a pervasive threat. It leads to this lifelong anxiety for patients, for their caregivers. It's huge.
The unpredictability, even with tiny amounts, must make daily life feel like a minefield.
Absolutely. Now, previous studies had sort of hinted that oral immunotherapy, or OIT,
Right.
could induce desensitization. That's like a temporary increase in how much peanut someone can tolerate through controlled exposure.
Okay.
But those earlier trials, they were often small, the methods varied.
That's robust.
Exactly. So official guidelines often advised against using OIT in just routine clinical settings.
Yeah.
It wasn't quite ready for prime time.
So avoidance was the only really reliable path, but it came with these immense psychological, practical burdens. Okay, so here's where it gets really interesting. Our first source, this is from the New England Journal of Medicine, published back in 2018.
A major journal.
Right. It details the PALISADE study. This was a big phase 3 trial that really put AR101, that peanut-derived immunotherapy drug, on the map.
It was a landmark study, really. In this trial, researchers were very rigorous. They screened participants aged 4 to 55.
A wide age range.
Yes,
Yeah.
we'll see the results varied. They confirmed the allergy by seeing dose-limiting symptoms.
Meaning reactions bad enough to stop the test.
Precisely. Significant breathing issues, maybe widespread hives, things like that. And crucially, at a very low dose.
How low?
100 milligrams or less of peanut protein. That's roughly just like 1/3 of a single peanut kernel.
Wow. Okay, so these were highly sensitive individuals.
Very. And get this, 72% of them had a history of actual peanut anaphylaxis.
So the most severe kind of reaction.
Exactly. It really highlights the severity of the group they were studying.
And the method they used. What did the trial actually involve?
Participants were randomly assigned, it was a 3-to-1 ratio, to get either AR101 or a placebo.
The gold standard approach.
Right. And they followed this escalating dose program.
Yeah.
Carefully increasing the amount over time.
Until they reached a maintenance dose.
Yes, a daily maintenance dose of 300 milligrams, and they stayed on that for about 24 weeks, so roughly 6 months.
Okay. And the results, what did they find?
The results were, well, truly compelling, especially for the children and adolescents, the 4 to 17-year-olds.
Okay. What did they see in that group?
At the end of the trial, an impressive 67.2% of those on the active treatment, on AR101, could ingest 600 milligrams or more of peanut protein without those dose-limiting symptoms.
600 milligrams, how does that compare to the placebo group?
Get this, only 4.0% in the placebo group could do that.
Wow, that's a massive difference.
Huge. A difference of 63.2 percentage points.
Yeah.
Highly statistically significant.
And what about the severity of reactions during that final test, the exit challenge?
Also much lower in the active group. About 25% experienced moderate symptoms.
Compared to
59% in the placebo group. And only 5% had severe symptoms compared to 11% placebo.
That's a fundamental shift. I mean, the game changer here seems to be moving from fearing tiny traces to potentially tolerating common accidental contact amounts. That 600 milligram level provides a real buffer.
Is a significant step from just avoidance towards actual protection.
But okay, this involves giving people something they're allergic to. What about safety? That has to be a major consideration.
Absolutely critical. And yes, adverse events, AEs, were common. Over 95% of those 4 to 17-year-olds on the active drug had some AE.
Over 95%. That sounds high.
It does. But let's break it down. Most were mild, about 35%, or moderate, around 60%.
Right.
A much smaller percentage, about 4.3%, were classified as severe.
So ADs are expected, but generally manageable.
That's the takeaway. Manageable within a clinical setting, suggesting, a favorable risk-benefit profile when it's done under medical supervision.
That's crucial context. And you mentioned the age range earlier. What about the adults?
Ah, yes, an important point. Efficacy was not clearly shown for participants 18 years or older in this specific PALISADE trial.
Interesting. So more effective in younger individuals, at least initially.
That's what this trial suggested, yes.
Okay, so PALISADE showed really promising results for that first year, fundamentally shifted the landscape.
Definitely laid the groundwork.
But a critical question always remains with these things. What about the long game? Does it last? Does it get better?
Right. What happens if you continue treatment beyond that initial period?
Exactly. So our next source, this one's from the journal Allergy, published in 2021. It dives into the ARC-004 study. This was an open-label follow-on study.
Meaning everyone knew they were getting the treatment.
Right. And it explored extending that treatment beyond the first year.
This was a longitudinal analysis, so looking over time. It explored the continued impact of daily maintenance dosing with PTAH, remember, the new name for AR101.
Okay.
Looking at efficacy, safety, tolerability, and importantly, food allergy-related quality of life.
And who participated in this follow-on?
These were participants from the original PALISADE trial, the kids and teens aged 4 to 17.
The group where it worked best initially.
Exactly. They continued to receive that 300 milligrams of PTAH daily for a total of about 1.5 or even 2 years, depending on when they entered.
Okay, so longer exposure. And what did they find? Did the benefits continue or plateau?
They continued and actually increased. The ability to tolerate peanut protein kept going up with longer treatment.
Really? How much?
So at the ARC-004 exit challenge, after about 2 years of treatment, 80.8% of participants tolerated 2,000 milligrams of peanut protein without dose-limiting symptoms.
2,000. That's way up from 600 milligrams after the first year.
Way up. Compare that to 48.1% who tolerated that much after only about 1.5 years total.
So dose duration seems key. Longer treatment equals greater desensitization.
That's what the data strongly suggests, yes. More time equals more tolerance.
2,000 milligrams, that's like what, 6 or 7 peanuts? That provides a serious level of protection against accidental ingestion.
It certainly offers a much greater margin of safety for everyday life. Major peace of mind potential there.
Absolutely. Now, what about safety over this longer period? Did the adverse events continue at that high rate we saw in PALISADE?
Interestingly, no. The overall and the treatment-related adverse event rates.
Yeah.
When you adjust for the longer exposure time, they actually decreased throughout this extended period in both the 1.5 and 2-year groups.
They went down.
They went down. The lowest rates were seen during this longer ARC-004 maintenance phase.
That's counterintuitive almost. You'd think longer exposure might mean more issues.
You might, but it suggests the body adapts, maybe. Also, study withdrawals due to AEs were notably lower here.
How much lower?
Only 2.1% in ARC-004 compared to 11.6% who dropped out due to AEs in the initial PALISADE trial.
That's a big drop. People were tolerating it better long term.
It seems so. Now, they did report accidental exposures outside of the study dosing more often in this open-label phase.
Which makes sense. Maybe people felt a bit more confident.
Possibly.
Yeah.
But crucially, the severity of the reactions they had from those accidental exposures and the need for adrenaline, very low.
Okay, so even when real-world accidents happen, the protection seemed to hold up.
That suggests a real-world benefit, yeah, moving beyond just the controlled trial setting.
I can only imagine the sheer relief for parents, for the individuals themselves, having this kind of option develop, that constant anxiety.
It must be debilitating.
What really stands out to you about these long-term findings, connecting them to the bigger picture?
For me, if we look beyond just the tolerance numbers, the key finding was the significant improvement in food allergy-related quality of life.
Ah, the impact on daily living.
Exactly. Participants and their caregivers reported clinically meaningful improvements in their quality of life scores.
And did that improve over time, too?
Generally, yes. The scores tended to rise with the duration of the PTAH treatment.
So not just a placebo effect of being in a study.
It strongly suggests a direct link. Increased desensitization seems directly tied to improved quality of life. Less stress, less anxiety about accidental exposure in everyday situations. That's profound.
Okay, so we've seen that it works. PALISADE showed that. And that it works long-term even better with ARC-004.
Right. The clinical picture is becoming clearer.
Now, for the really fascinating part, at least for me, how? How does this therapy actually do it? What's changing inside the body?
The mechanism, yeah.
Our final source, also from Allergy, this one from 2022, is a mechanistic sub-study of PALISADE. It looks right at those dynamic immune responses, cellular level stuff.
Exactly. This study aimed to really get under the hood. Understand the immune mechanisms that AR101 PTAH triggers to actually cause desensitization.
How did they do that?
They looked at changes in two key types of immune cells in blood samples from the participants. First, basophils.
Basophils, okay.
Think of them as the body's immediate alarm system for allergies. And second, specific types of T cells, which are more like the immune system's master strategists.
Okay, let's start with basophils. What exactly are they, and what did the study find about how they responded?
So basophils are critical effector cells. They're the ones that release histamine and other chemicals causing the classic allergy symptoms, itching, swelling, breathing trouble.
Got it. The immediate reaction, guys.
Right. And there's a test called the basophil activation test, or BAT. It basically measures how sensitive these cells are to the allergen, in this case, peanut protein.
What did the baso show?
It showed that in the allergic individuals before treatment, their basophils got activated at very, very low concentrations of peanut protein. They were hypersensitive.
Makes sense.
Now, the peanut oral immunotherapy, the POIT, with AR101 PTAH, it significantly decreased this basophil sensitivity in the active treatment group. Meaning you needed higher concentrations of peanut extract to actually trigger a response from their basophils after treatment.
So the alarm bells became much less sensitive to peanuts, less jumpy.
Precisely. Less jumpy is a good way to put it. And this shift closely paralleled the clinical benefits they saw, the increased tolerance.
What about the placebo group's basophils?
Interestingly, the placebo group actually showed increased basophil sensitivity over time.
More sensitive, why?
Likely because they kept having the food challenges during the study, but weren't getting the desensitizing therapy. So repeated exposure without intervention might have even primed them slightly.
Huh. Okay, so the therapy actively dials down the sensitivity of those immediate responders.
Yes, but an important nuance. That decrease in sensitivity in the treated patients, it didn't fully reach the level seen in people who were peanut sensitized but non-reactive to begin with. Yep. Meaning even a year of this desensitization might not be enough for complete, sustained unresponsiveness if you stop the treatment.
Yeah.
But it's a very significant step towards it.
Okay, still a major improvement. Now, what about those T cells? You called them the strategists. That sounds fundamental.
It is pretty fundamental. T cells really orchestrate the whole immune response, including allergic reactions.
So they're directing the show.
In many ways, yes. This study focused specifically on peanut reactive T effector cells, or PTEF cells.
Yeah.
The ones that react to peanut.
Okay.
And a key finding involved a specific subset called Th2A cells.
Th2A, got it.
You can think of these Th2A cells as the main instigators or drivers of the problematic allergic response. They're considered pathogenic in this context.
Pathogenic meaning they cause the trouble.
Exactly. And they found these Th2A cells were strongly correlated with higher baseline levels of peanut-specific IgE, that classic allergy antibody.
Okay, so high Th2A means more allergic profile.
Generally, yes. Now, how did the treatment affect these specific cells?
That's the question.
The active treatment with AR101 PTAH caused a marked decrease in the frequency of these circulating pathogenic Th2A cells.
It reduced their numbers.
Significantly reduced their numbers in the blood. This means the therapy is actively, you could say, reshaping the T-cell landscape of the immune system.
Wow.
Another type of T-cell they looked at, CCR6 plus PTEF cells, these tended to correlate negatively with IgE, and their numbers remained relatively constant.
So the therapy was selective.
It suggests a selective process, yeah. Maybe specifically targeting those harmful Th2A cells for exhaustion or deletion, as the researchers put it, effectively turning down the volume on the most severe allergic signals.
That's truly fascinating. So it's not just masking the allergy, it's actually reducing the number of the specific cells that drive the worst reactions.
That seems to be a key part of how it works at the immune system level.
So what does this all mean for us, tying it all together?
Well, we connect this back to the bigger picture, the changes in these immune biomarkers.
The basophil sensitivity going down.
Right, and the decrease in those pathogenic Th2A cells.
Yeah.
They closely mirrored the clinical improvements, the increased tolerance, the better quality of life.
So the mechanism matches the outcome.
It provides a powerful explanation for how OIT works on that cellular level.
Right.
But more than that,
yes,
it also suggests that things like basophil activation, the beat test, and maybe tracking Th2A cell levels, these could potentially become important biomarkers.
Biomarkers to do what?
To monitor how well the treatment is working for an individual, maybe even to tailor therapy in the future. Imagine personalizing treatment based on these precise cellular shifts.
That's the future, isn't it? Precision medicine for allergies.
It certainly points in that direction.
This deep dive has shown us just an incredible journey, really, in treating peanut allergy.
It really has been transformative research.
From proving initial efficacy in those big clinical trials,
Like PALISADE,
to understanding the long-term quality of life improvements.
from ARC00.
And now, getting a handle on the complex immunological shifts that actually make it all possible.
The mechanistic insights.
It's clear that oral immunotherapy like PTAH is genuinely changing lives, helping people build tolerance, reducing that awful anxiety of accidental exposure.
Yeah, the evidence that continued treatment not only boosts tolerance, but actually refines the immune system's response is, well, it's remarkable.
That reduction in the pathogenic Th2A cells you mentioned.
That in particular points to this profound ability of the body to adapt, to sort of relearn, moving towards a more regulated, non-allergic state.
It's like reprogramming.
In a way. And this raises, I think, an important question for you, the listener, to ponder.
Okay.
Considering how deeply science can now understand and even reshape our immune responses, what other chronic conditions out there, things currently just managed symptomatically.
Right, things we just live with.
Exactly. Might they one day be essentially rewired at a cellular level for true long-term change, not just symptom management?
Moving beyond allergies, you mean?
Potentially. Think about that as you go about your day. Where else could this kind of deep biological reprogramming make a difference?